All right, good afternoon. As I said, Friday means it's time to record some biochemistry. And actually, thank you for singing happy birthday to me earlier. I have it on recording, but I promise not to release it. But it actually is something that I enjoy to do, to find papers like this one and to show you what they mean, because they can show hidden connections that we weren't aware of before for something very common for food that we all eat. Which cuisines are more like the other cuisines? You can taste this, but the tastes are very different, right? Are there other characteristics that maybe could say that this one kind of food is like this other kind of food or more like this than the other ones are? These kind of relationships. And this kind of thinking actually will show up again. We're going to use it to look at protein folds and structures. And I've got a great paper, so that's why I like this paper. And I'm going to take some time on it because I can. Okay, so chemical food pairing. Remember that we are talking about the idea of molecular gastronomy, where you have foods that share an ingredient. And so because they share that ingredient, you put them together. You can do this at the level of the ingredient, which is a bunch of chemicals, or you can do this at the level of a single chemical, which can have surprising connections. So we mentioned the chef that noticed that both white chocolate and caviar have trimethylamines. And so he tasted them together and he's like, that's weird, but they actually go together because they share trimethylamines between them. Now there's two ways you can go with this. You can put two foods together, just like two colors together that are similar. You can put two foods together with similar chemicals. That's called the food pairing hypothesis. Or you can deliberately go the other way and have contrasting flavors. You can have ingredients that do not share compounds. And it turns out we're an inventive species. We have come up with both different ways to do it for different areas. So there are some other things about molecular gastronomy you can look up, but I want to focus on this paper today, which came out relatively recently, that looks at food pairing from a network perspective. Now, what do we mean? So you have a list of the ingredients, and let's say the ingredients, of course, are complex mixtures of flavor compounds. We actually know enough about the predominant flavor compounds to have a pretty good idea of which flavor compounds, which chemicals are in which ingredient. Look at those chemicals and you'll recognize them as organic chemistry, or in some cases we have some biochemistry things that are coming down the road. Dimethyl succinate. We're going to talk about what succinate is. We've talked about acetone. That actually shows up in life as well. Most of these are organic chemicals and biochemicals. And you see that there are different ones that are associated with different ingredients. So we can say, do chefs put together things with the same chemistry in them? Or maybe they put things with contrasting chemistry in them. The first question they ask is, what is the prevalence worldwide of ingredients in all recipes that they could collect? So just look at this, and you can see the biggest picture is the most prevalent ingredient. Everybody loves garlic, right? So you look at that and you see what's second best. Well, you see a lot of connections. When you have garlic, you can also have a lot of scallions. If you have scallions, you're going to have them with garlic because there are shared compounds between scallions and garlic that show that they're very close in the flavor network. And so in some cases, garlic and scallions together would be a shared ingredient kind of hypothesis. You can look on the other end. You have olive oil on the other end. What else can you see? You can see soy sauce and tomatoes are also popular. And you can say mozzarella cheese is actually less popular worldwide because they use a lot of that in certain cuisines, but they don't use a lot of that in Asian cooking, for example. So you can look at these, but when you're using mozzarella, a lot of times you're using it with Parmesan. See that thick line? They share many shared compounds. If you are using both mozzarella and Parmesan, you are implementing the food pairing hypothesis. This is all great because I love looking at normal things with science. One of the things they can find out is, so this is a very simple question to ask, which cuisine has the most ingredients per recipe? And I want you to look at that, and we have 5 cuisines. I believe, if I remember correctly, we have East Asian, we have Southern European, we have Latin America, we have Northern European or Western European. I forget which one they have, but it's definitely like the France, England kind of thing. And then we have North America. So out of those 5, you can see that there are 2 of them that have fewer ingredients per recipe and 3 of them that have more. So I want you to take your favorite and guess whether it has more ingredients or fewer ingredients per recipe. So these are the ones with the most: Southern European, Latin American, and East Asian. And I know from cooking East Asian food, I've got to go to the supermarket usually because there's always something that they need that I don't have, and several things. So I go to the Ranch 99 market. It's lots of fun. I look for any excuse to do that. So North American and Western European have fewer ingredients per recipe. And look at how, of course, that's a distribution. You have some that always have 15, you have some that always have 5. But you have more with more recipes with fewer ingredients for North American and Western European. So now the food pairing hypothesis, let's put some numbers on this. When foods are paired, the food pairing hypothesis is that we want to put together foods that share chemical compounds. Like that chef that we mentioned was following the food pairing hypothesis for a very focused one ingredient. Do people do that intuitively or not? Or do they have contrasting things? Coffee and beef actually share a lot of flavor compounds. So if you put those in the same recipe, you are following the food pairing hypothesis. Lemon and shrimp, on the other hand, are very different chemically. They have few shared compounds, and if you put them together in a lemon shrimp sort of cuisine, a recipe, then you are not following the flavor contrasting idea. And the really cool thing is they found that there's a basic difference between Western and Eastern cultures, with the most pronounced difference between North American and East Asian, that in which one follows the food pairing hypothesis and which one says we want our food to contrast. So I want you to think about, which one do you think it is? Which one do you think pairs their food together with shared compounds? They already have the same chemistry at many levels. And so you put together things that have the same chemistry as opposed to things that contrast. See if you're right. This is the chart right here, and there are extremes. Up means you have more shared compounds, more flavor pairing, food pairing. North America is basically apparently North Americans just put together things that already have the same flavor compounds in them. Ingredients that share chemistry are put together a lot. Look down at that chart. The ones that are to the right are compounds with shared sort of chemistry. And you see egg, butter, milk. They're kind of similar chemically. They're fatty, they're creamy, they taste kind of the same. They're definitely different than like lemon or shrimp, right? So, and they're often together in North American recipes. Western European is almost the same, it's just not as extreme. On the other end, we have East Asian recipes, which will put together things that have very different chemistries for contrasting flavors. And you notice the interesting thing here is also, well, who's a lot like the East Asians? Southern European cooking, which I believe is Italian and Greek, although it might be more Greek than Italian. I'm not sure where you put Italy because it's kind of west and south. But Southern European, the way they've done it, is a contrasting kind of example. I think it'd be like, like borscht and like East Europe is what we'd say. Anyways, you can look at the paper if you want to know more. I encourage you to look at it, and you can probably find it online from the title that I gave you. So they set up these food pyramids where they put the 6 most authentic ingredients that represent that cuisine at the top. And then they said what ingredients pair together and how many shared compounds do these ingredients have, and how many triangles of these ingredients share compounds as well. And you look at this and you just see a lot of thick lines. There are a lot of chemicals shared between butter and milk, between egg and milk, between butter and vanilla. And those are often put together in North American recipes. On the other hand, East Asian recipes, they have these 6 authentic ingredients at the top: soy sauce, sesame oil, soybean, ginger. And those are paired together. These are how they're paired together, and they have hardly any lines between them. East Asian cuisine will pair together things that have very dissimilar chemistry. There are thin lines and they don't share any chemicals. So you're sort of making these contrasting chemical mixtures. In fact, it turns out that if you look at the 6 most authentic ingredients for all the cuisines, and it's interesting to look at what is the most authentic ingredient that is used the most in that particular cuisine. There's overlap between East Asia and Latin America, and between Latin America and Southern European. Everybody in there loves garlic, okay? At the bottom, we have North American cuisines, and what's distinctive about North and Western cuisines are that they have a lot of the shared ingredients have shared compounds. They're very similar. So you have this sort of thing that you're combining it. And you can even go to what does that mean at a different level. Is there some idea that the recipes are a lot the same, but then maybe you can put different structures in. If you make like croissants, right? It's very different from making bread, and yet it's similar ingredients. So maybe there's more distinctiveness at the North America, Western European at the structural level, but there's not much chemical distinctiveness to how they put together their recipes. Anyways, I think this is fascinating, but this is something you're familiar with. Be able to analyze and to think this way and to say, what do these graphs mean? It's going to be important when we talk about proteins, and it's going to be important for stretching your mind and learning new things, which is what biochemistry is about. So that's the end of this mini lecture. We have 2 more to come.